So before we get into the main part of this lesson, I want to show examples of inequalities on a graph. Now right here we have the line 2x plus 4 with an equal sign. Now when it's an equal sign, it just has a solid line and it shows the line as it goes off the graph. If we have an inequality, we are basically saying we're taking all y that are greater. So if y is greater, I always recommend going to the y-intercept, and we want y that are bigger. Draw some arrows. Anything above this line is greater than 2x plus 4. So to show it, we're going to just shade that part of the graph. So we start with the actual line, we draw the line, and then decide, is it above the line or is it below the line? I always recommend focusing on the y, it's the easiest, and just go to the y-intercept and am I going up or down? So another example is right here. This line on the graph is negative 2x plus 3 with an equal sign, but we want to turn it into greater than. So in this case, it's greater than, just like the last one. Go to the intercept and go up. All y's that are greater than the one that we have. So it doesn't matter where you go on the line, it's always up. And we shade it in to show that it's all these are the solution. Anything in this area is a solution to this graph, the inequality. It's a little trickier with parabolas, but the idea is the same. So we started with an equal sign, we drew the parabola, and now we need y that are smaller than. So the y-intercept, and I want smaller than. No matter where I go, it has to be smaller than the current parabola. So the solution is everything around the outside, underneath the parabola. This one here, we started with negative x plus 1 squared plus 4, but we want smaller than. So if we go to the intercept, smaller is down, so it's everything underneath the parabola. Because it's facing down, it's kind of inside. And we show this by shading in inside or underneath the parabola. This is all the solutions to this function. So now let's try some examples in the notes package. So what we learned in the last lesson, x is less than 3, white dot, and point the arrow. X is greater than or equal to 4, and greater. So we have two different things to show. Now, if we want to show this on a graph, x is less than 3, we're going to go to the same spot. Now the problem is we can't show the white dot, but we can show a dashed line. And this is the same thing as a white dot. We've got holes in the middle. It says the solution comes up to 3, but does not quite touch 3. So instead of just one circle or one dot, we now have a whole line, and it's everything less than 3. And we show it that way. Here, y is greater than 4. So I'm going to go to y is 4. Now it's got an equal sign, so it's a solid line. And this time, y is greater than 4 is above. So x is less than 3 is on this side, on the left. Y is greater than 4 is on the top. Now we're going to get into lines. So we're going to plot these lines. And always check, and it's always good to use pencil for these. This is no equal sign, less than. So I have to put a dashed line. So make sure to put this in. If you do it by accident, using pencil means you can just erase some gaps in between. And we have to show less than. Less than is going down. So it's key to shade in everything, but have a dotted line on the edge, on the boundary. This one has an equal sign. Start at 2, down 3 over 1. And I want y is less than. So less than is going down. So it's that area of the graph. So draw the line, make sure you have it dotted or dashed line or solid, depending on if it's equal or not, and then shade in. Just, are we going above or are we going below? So what I want you to do is pause the video at this point, try these graphs out. If you can, even go to these ones. Keep going till you get stuck. Play the video once you need to check. So less than 3, this is y, and no equal sign. Y is less than 3, so I'm going down. -1 equal sign. And I want bigger than 5/2 x. And this one is greater than. And we want less than. Now, all of these just had one line in them. These ones have 2. And so what we're going to do is look for a section that has both working. Now this one is the trickiest one. I've got plus y is less than 10, so I'm going to focus on the y coordinate. So this means I want less than the line. I want less than this. So I'm going to draw 2 arrows just to kind of guide me for now. I don't know if they're going to be shaded yet. Then I go to this one and I see -2y is less than 12. Now the problem with this one is it's got a -y. As we learned last lesson, if we divide by a negative, the sign flips direction. So I don't even care about the x. This one I just said y is less than. Because this one has a negative, I'm going to flip the sign because I'm dividing by the negative. That means I want y that's greater than -6. So because I have 2 lines, I have arrows going up from this one and arrows going down from this one. And you'll notice that this is the only section with arrows pointing in from both lines. This one doesn't have an arrow here. This one doesn't have an arrow there, and this one has no arrows. So there's only one of the 4 sections that will have arrows from both lines showing. Now, one of the things I want to emphasize is it's always good to use pencil, and the reason why is you want to check. This one has an equal sign, so this line should be solid. This one doesn't, so this one should have had a dashed line. So use pencil. And once you're done, this one's dashed, this one's solid. The solution is everything in here. Now keep in mind, the solution goes up to and touches this line, but does not touch this one. So different options for both. So try this one on your own if you haven't tried it. Graph it, and we'll check the answer. So we've done both lines. This one's dashed. This one is solid. The first one, y is greater than. So arrows pointing up. This one's y is less than. Arrows pointing down. And the only section that has both arrows pointing is this section over here. Like that. So try the questions below, see how you do.